Okay. All right. Welcome back, everyone. So today we're going to be continuing from Monday's demo about ORMs. And just as a quick recap, we were working on db.py over here. And the main things that we did were we implemented this task class over here with all these fields as the init function and the serialize function. And we have the subtask class over here, which has all these fields. We have this task ID over here, which is in a foreign key relationship or one-to-many relationship with this task model. And the kind of syntax of all this stuff is that the ORM allows us to have kind of an object-oriented method of coding as opposed to like raw SQL commands when we had in previous demos. And so this makes it nice so that our db.py kind of creates our blueprint for like what our models are. And then we have all of our logic in app.py. So we have our models here, and now we can start with writing some basic routes. So the first route, I guess we're gonna want to implement is this get tasks route. I know we don't have anything in the database yet, but this is just gonna be a check that our, I guess, app is working fine. So we're gonna go over here. And so we're gonna first implement this like the traditional way that we've been doing it in class, and then I'll show you like a faster, not really faster, but just a shorter syntax way. So the first thing we're gonna want to do with this get tasks method is initialize some empty list called tasks. And then, so in previous demos, we had like a function in DB over here that we could use. So it was like get all tasks, and we'd have like a query which was like self.con.execute, select all from task or something like that. Well, with ORMs, they actually have pre-built-in functions which allow us to do those with just one simple function call. And the way we do this with SQL Alchemy is simply doing task.query.all. And before, I guess, I talk about this, make sure you have imported over here. You say from DB import task and subtask. And so what this is doing is it's importing these two classes that we created in our db.py file. So what this basically does is that task.query.all is the SQL Alchemy function for getting everything from the database. Task is the class that we're referencing, so which is what we defined over here. And we're basically querying everything of like a task object. So this is how we do that. And so we have to, I guess, store it in some variable. We named it cursor last time, but we know that this is just going to be some object. And eventually we're going to like want to loop through this, get everything, and then kind of append it to this empty list and then return it. So what we're going to do is we're going to say for task in task.query.all. We're going to go over here, and within the for loop, we're going to want to append each task to this list. So we're just going to do tasks equals or tasks.append. And then we don't just want to do task because this is some random object, and maybe like the way this object is like in Python, the way it's displayed might not be nice. So we can use this serialize function over here to kind of display it in a nice dictionary, right? So we're going to do tasks.append task.serialize. And then at the end, we can just return a success response. And that's going to be a dictionary called tasks. And then it's simply just going to be our tasks list over here. So let's save that. Let's get the app running real quick, see if this works. I already have it running. So let's go to Postman and see if this thing works. So we're in demo 4, get all tasks. And theoretically, if I press send, okay, there we go. So we have an empty tasks list over here, which is good. So our app is working. So now the faster way to do this, well, not really faster, but shorter syntax is instead, let me comment this out over here. What you can do is you can say return success response. We're going to do this all in one line of code. We're going to have our tasks over here, which is like the first key in our dictionary. And we're going to do t.serialize for t in task.query.all. And so what this basically does is that we have this task.query.all, right? This is going to get all of our tasks. Then for t in task.query.all, we're basically getting each task in, our task database. And then we serialize this task. And then since this is in brackets over here, this is stored as a list. So this basically does all of this, but in one line of code, which is pretty cool. So we're going to be using this type of syntax in some of the serialized functions later on. So this is, I guess, good to know and kind of cleans up your code a little bit. So we have this. Let's save it. Let's make sure that this actually works. Oh, okay, there we go. All right. So the next thing we're going to want to do is probably insert something into our database, right? Because we have no data in it, so it's worthless. So let's go and implement this create task method over here. So first, we're going to have some sort of request coming in, right? So we have to have body equals JSON.loads request.data. Then we have, and I forgot to say, make sure you're importing request over here. So from Flask, import request. Yeah, I think so. Yeah. So this is what allows you to like get data from your request body. So we're over here. And so the next thing we have is our new task. And so this is going to be encapsulated in our like task object. So you have this, and then we just have the different fields of our task, right? So the first thing we have is a description, and that's going to be body.get description. And then our done field, which is body.get done. So now that we have our new task, we have to add it to our database. And again, SQL Alchemy has another built-in function for this. What we can just do is say db.session.add new task, and that adds our new task to the database. So I guess what I'm trying to hammer through is that these two functions right here, this is really the power of ORMs, is that we don't have to use these raw SQL commands anymore. This code is way more readable, and it's just a lot easier to program with these ORMs. So now that we have this, we still have to like save our changes, right? Remember we had self.con.commit in the previous demo. So there's a similar function in SQL Alchemy, and we're just going to do db.session.commit. And then after this, we just return the success response. And this is going to be our new task. Again, we serialize it to make it return in a nice format. And then the response code for this is 201. So let's go back to Postman and try to create a new task. All right. So we're in the body. I do need to exercise today, so we'll have that as our description. And I haven't done that yet, so it's false. And let's send that through. All right. So we see that our task was returned to us. So now let's go to get all tasks. And we see that we have a good task over here, which is the one that we just created. So now that we have this, let's go implement our get task by ID function. So we're back in over here. Let's implement get task. So again, SQL Alchemy has another built-in function for this. Since we're querying from the task class, we do task.query.filter.by. And what you probably can guess is that we're filtering by some sort of like metric, right? So if we're getting task by ID, we're probably going to be filtering by ID, right? So we're going to have in our, as a parameter, ID equals task ID. And then the thing about the filter by is that we want to get the first instance of this like ID. Normally this should only return like one instance because our ID is like our primary identifier. But I think it's just because of syntax, we have to say dot first over here. So this is going to get our like desired task, right? So we're just going to store this in some variable. Then we check if our task is none, which indicates that we haven't found it, right? So we're going to return a failure response, and this is just going to be task not found. And then if it is found, we just return our task serialized. So return success response, task.serialize, and that's all good. So let's go over here. So we have get all tasks again. Let's go to get task by ID. We created one task, so let's see if this works. And indeed it does. So let's just create a few more tasks over here. So say do 3410 project. And then, I don't know, work on resell. All right. So then let's try to get the second task since that's in the middle. And there we go. So we got our desired task. So this function is working. So now that we have our get task, create task, and get all tasks, the next logical step is for the U and CRUD. So we're going to do update task. So we're over here. And so since this is a post request, since we're posting this like task ID in here, or not task ID, but we're posting some sort of like data into our database. There's going to be a post request. And so the first thing we're going to want to do is get our body, get our request body. So body equals json.loads request.data. Then we get our task through our get task by ID function. So we have task equals task.query.filter by. We have our ID is equal to our task ID. And since we want to select the first instance of it, we just say dot first. Then we check if our task is none. Then we return the failure response, task not found. Then, so if our task is found, then we want to update with whatever is in our body, right? So we're going to say task.description. Since description is our field in our task model, we can just say task.description over here. And we can just say this is equal to body.get description. And likewise, we can say task.done equals body.get done. And so now, since we've like updated this task object, we've changed these fields. We don't actually need to like send like a query to the database. With the ORMs, if we just simply change like the values of this object, that's going to change like the values in the database. But we have to save these values. So we're going to do again db.session.commit. And then lastly, we're going to return success response. And this is just going to be our new task serialized. Okay. So let's go test this in Postman. So let's get all of our tasks. Let's see what we got going on. So let's say that I exercise after this and I make this true. So let's go to update task by ID. I think this was ID of 1. So yeah, let's go done is true and send this in. Okay. So we have an error. Let's see what this is. Line 80. Pretty sure I have to have a description in here. Okay, there we go. So what I forgot was I'd have a description in the request body. And I also did JSON.load instead of JSON.load. So this method now works. If we go back to get all tasks, we should see that this has been marked with true over here. So we've done get all tasks. We've done get task by ID. We've created one. We've updated one. Now let's say I want to delete some tasks. So we're gonna implement this method next. So we're in here again. Since we're deleting the task by ID, we want to first search for this task. So we're simply going to do task equals task.query.filter by ID equals task ID. And we're going to get the first instance of this task. If it's none, then we just say return failure response, task not found. Then again, SQL Alchemy has a built-in function for deleting. We don't have to do that delete from table stuff or whatever. All we have to do is simply just do db.session.delete. And this is just the task that we're passing in. So now we've made a change to our database. We have to commit this change. We have to save it. So we do db.session.commit. And then lastly, we're going to return the task that we just deleted. So success response task.serialize. All right. So let's see if this one works. So let's say I want to delete the task of ID 1. So we're going to go to delete task by ID. This is the URL. We have ID of 1. Okay. So this is JSON. And let's go to get all tasks, and this should decrease by 1. There we go. So now all these CRUD endpoints are working. And so now let's move on a little bit more to the subtasks. So first thing we're probably going to want to do is create a subtask. And remember that they're in a one-to-many relationship with a particular task. And we've already modeled this since we have a foreign key in our subtask object that references the ID field of the task object. So we're here. We have this field over here, task ID. And this is a foreign key that references the ID field of the task model. So we have this relationship already here. We can simply code up the route since we already have the blueprint for this. So we're in here. And so since we're passing in a particular task ID, we're going to first search if that task is actually valid. So we're simply going to do task equals task.query.filter by. The ID is the task ID, and we're going to get the first instance of this. Then if our task is none, we return failure response, task not found. Ooh. And yeah, so now that we found a task, we actually want to create our given subtask, right? So since this is a post method, we're going to have some sort of body coming in. So we say body equals json.loads request.data. And then in our body, we're going to have some sort of description done, and then also a task ID, or not, sorry. The task ID isn't going to be in the body, it's going to be passed through the URL. So we have all the data we need to create our new subtask. So we simply have our new subtask over here. And the way we create this is just having a new subtask object being created. So the fields of this are description was body.get description. We have our done equals body.get done. And then we have, let's here, our task ID. And this is going to be just our task ID that's passed through the URL over here. So now we have this. And now the way we add something to the database is just db.session.add new subtask. We save the change that we just made. So db.session.commit. And then let's return our new subtask. So this is going to be new subtask.serialize. And again, this is going to have a response code of 201. So we've created our subtask, and let's see if we can go to Postman and create one. So in our get all tasks, we have ID of 2, do 3410 project. So let's go over here, change this to 2, and say fill in our type requests. And I haven't done that yet. So let's see if I can post this in. And so we see we have our subtask over here. And in our get all tasks, we still can't really see our subtasks under it, which is something that we're probably going to want to do right now. So yeah, so let's say we want to see this subtask over here that I just created under the get all tasks. So the way we display our task is through the serialize function. So the thing that we have to do in the serialize function is have some sort of subtasks field in here that's going to kind of detail all the subtasks. But we have no way of referencing them just yet because we don't have a field for them up here. So what we're going to want to do is we're going to want to have an extra subtasks field over here. And so we have subtasks equals db.relationship. And so to represent the relationship with subtasks, we're going to use this command over here, relationship. And the first parameter is just going to be the name of the class, which is subtask. Make sure you're spelling this with capital S because this is the name of the class. And so after that, we have something called cascade equals delete. And so this cascade thing means is that, let's say I have a task and I have like 5 different subtasks of it, right? And since they're in a one-to-many relationship, each subtask references that particular task. And so let's say I delete this task from the database, right? So then what happens to all those other subtasks? Do they just stay in the ether or do they get deleted along with it? So what this cascade equals delete means is that if I delete a particular task, then all of its children or subtasks are also going to be deleted as well. So in this, I guess, what I did in Postman is I had an ID of 2 for the task and an ID of whatever for the subtask. If I delete my task of ID 2, then that subtask that I just created will just be deleted as well. So this is what this cascade equals delete thing means. So now that we have subtasks over here, we can now serialize our tasks or serialize our subtasks within a task serialization. That was a little confusing, but all right. So we're going to have over here. Okay, so then we're going to have subtasks. And again, we're going to use this like special syntax. So we're going to do s.serialize for s in self.subtasks. And so this is basically going to do is for each subtask that we have of this task, we're going to serialize it and we're going to store it in a list. Okay. So let's go to Postman and see if we can get all tasks over here. So go to JSON and we see that since we created a subtask under this one, it's now showing up under here. So this is how we, I guess, display like the subtasks of a given task. All right. So then now we have all of this, and now I'm gonna create a many-to-many relationship between tasks and let's say categories, right? So let's say one task can be part of many categories and one category can have, or sorry, one task can be part of many categories and one category can have many tasks that are part of it. So yeah. So we're gonna go to the category model over here. Let's create a new one. So we're gonna have a class category. This is again going to be a db.model, and this just tells SQL Alchemy that this is like another table in our database. So we have this over here, and this is simply going to be our category model. Okay, so first we have to have a table name for this table, and this is simply going to be categories. And then, so some fields that we're going to want to have for categories, let's say we have like an ID, some description of this category, and I guess usually some colors are associated with it. So like if you look on Google Calendar, there's like different colors for like different events and you can have different colors for them. So let's say we have like a different color. And then lastly, we're probably going to want to relate each task to its category. So we're going to have like a tasks field within our category model. So we're going to have first the primary identifier, which is just the ID. So we're going to have db.column. This is going to be an integer. It's going to be a primary key since it's our primary identifier. And then we're going to set auto increment is true so that whenever we create a new category, its ID is just one above the previously created category. So we have this, then we have a description, which is again going to be db.column. It's going to be db.string. And we're going to want this to always have a description. So we're going to set nullable equals false. Then we're going to have a color associated with this category. So db.column. Again, this is going to be db.string. And we're also going to want this to be nullable as well. Then the last thing is going to be the tasks associated with each category. So we're going to have tasks equals db.relationship. This is going to be associated with the task class over here. So we go over here and we say task. And then, so now this is a little trickier because the relationship between tasks and categories is going to be a many-to-many. We want one task to be associated with many categories and one category to be associated with many tasks. So we can't really say that our secondary is just going to be like some sort of foreign key, right? Because that's only one, I guess, that's a one-way relationship. That's a one-to-many. We're going to want to have like a one-to-many from categories to tasks as well. So we can't just have like a foreign key like this and expect to have the same kind of relationship. So what we're going to do is how we talked about previously. Does anyone remember how we implement many-to-many relationships? There's something that we do. There's something that we create that links one, I guess, entity with another. Does anyone remember how we do that? Yeah, so we do it with an association table. So we're going to say our secondary is, let's call it association table. We're going to create that in a minute. And so we're going to say back populates, which is another parameter in here. And this is going to be categories. Yeah. So then we're going to implement this association table all the way up here. Okay. So we have association table here. And the way we create this in SQL Alchemy is we have a db.table. And so now we're going to specify some different, I guess, fields within this table. First thing we need to do is name this thing association so that we can associate it over here. Or never mind. My bad. We just have to name it something. Then we have to specify that there's some metadata associated with this. It's just some syntax from SQL Alchemy that you really don't really need to know. You just need to know that it goes there. Then, so the two things that we're going to want to have in this association table are some task ID and some category ID. And what this is going to do is going to map one task ID to one category ID, indicating that there's a relationship between those two entities. So first, we're going to have a db.column, and we're going to name this thing task ID. This is going to be an integer because our task IDs are integers. And this is going to be a foreign key that references the tasks or the ID of the tasks field over here. So this is one, I guess, one way of our relationship. Now we need to create the other way. So similarly, we're going to have another db.column. This is going to be category ID. This is going to be another integer since our categories have integer IDs. And this is going to be a foreign key, which represents the categories ID, the ID of the categories table. And yeah, so this is all that really goes into association table. I spell foreign. Oh, foreign key. Okay. All right. So now we've defined an association table with two different foreign keys over here, one with the task ID that references the ID of the task field of the task table, and then a category ID, which references the ID of the categories table. And so the last thing we need to do is update our task model. So we had our tasks over here for category. We had this thing over here. So now we have to create another field in the task ID that's going to store the categories of a given task. So we're going to go up here and say categories equals db.relationship. This is going to be referencing the category class. So we're just simply going to say category. Our secondary is going to be an association table, which we defined earlier. And so we're going to say back populates. It back populates the tasks table. So what this back populates field means is that it allows us to make a bidirectional relationship, essentially. So if we make a relationship in one direction, it also makes a relationship in the other direction. So it's kind of similar to the association table, but what it basically does is that let's say I have, let's say I create a category for a given task, right? And this categories field now has one category associated with it. So what this back populates tasks thing does is that if I create a category, this field over here is going to be populated with the task essentially. So this is what I guess the back populate field does. So now that we have this, we can go create a serialized function for our task over here. So we want to see like what different categories are associated with it with a given task. So over here, we're going to say categories. And this is going to be, again, using that kind of special syntax we saw earlier, c.serialize for c in self.categories. And so again, let's say that we want to see the tasks of a given category. We're going to go to a category. Oh, I realized I didn't initialize this. Okay. So in the category class, we also have to have our init and serialized functions. So let's just define those now. So we have init over here. We're going to take itself and its keyword parameters in. And so this is going to initialize a category object. So what this is going to do is just set these fields basically just equal to whatever they are. So we're going to have self.description is equal to our keyword arguments dot get description. And then self.color is equal to keyword arguments dot get color. And then, so we've initialized this. Now we're going to want to display it in some way. So we're going to define a serialized function. So it's going to take itself as a parameter. And so it's going to serialize category object. And so we're going to have here is we're going to return a dictionary. And this is just going to be the ID, which is self.id. We have our description, self.description. And we're going to have our color, which is self.color. So let's say, since we have a menu with categories and tasks, let's say we want to see all the tasks for a different category. So like up here, we can do the same thing as down here. So what we're going to say is tasks, and then we're going to say we're going to do t.serialize for t in self.tasks. So now we have this, but does anyone kind of see like a problem with, since this is a many-to-many, serializing the categories in here and also serializing the tasks over here? Does anyone see like a big problem with doing this? Yeah, exactly. So every time we're serializing like a task, right? We go to serialize a category. So we jump over here, right? So we serialize this category, but then we serialize every task that's associated with this category. So we're just going to keep bouncing around in these serialized functions till the end of time. So one way to get around this is just to have a simple serialized function that doesn't serialize all the tasks with that are associated to a category. So what we can do over here is we can define a simple serialized function, which takes itself as a parameter. And this is simply going to return everything that this function has, just without the tasks over here. And so we have this. So now going up here, instead of saying c.serialize for c and self.categories, we can just say c.simple serialize. And so this prevents that infinite loop from happening in our database. So now that we have like different tasks and categories, let's try to, I guess, assign some categories to different tasks. So in our endpoint, we kind of have two things to consider over here. Yeah, so there's two things. First, we have to look for the task, and second, we might have to look for the category. Because if the category that we want to assign to a task already exists, we should just then use the one that is already existing in the database, right? So like when we're creating a subtask, like subtask can only be related to one task. So we don't need to check if this subtask is kind of already in the database, right? But with the category, if we're assigning multiple categories to a given task, we need to check if that category actually exists or not. So first, we're going to start off looking for a task. So we're going to go over here. And so we have a task ID over here. So we're going to say task is task.query.filter by, our ID is our task ID. And we're going to get the first instance of this. Then if task is none, then we return the failure response, task not found. So then after this, now we need to see if our category actually exists. And the way to do this is we have to actually see the body that is being sent through the request. So we have our body equals json.loads request.data. We have our description, which is just our body.get description. And we have done, just body.get done. So now, let's say that, or no, sorry, not done. Okay. So let's say a category of this color already exists. We need to see if that's actually the case. So what we can do is we can say category equals category.query.filter by color equals color. And we also have to import the category class up here. So we have task, subtask, and category. So scrolling all the way down here, and we get the first instance of this. And so if our category is none, then we say that our new category is category, which its description, simply its description, and the color is equal to the color. For now, we're saying that multiple categories can have the same description, but in general, like we're querying based on the color, so we don't want two categories to have the same color. So then we have this. So we either have that our category either exists, and if it doesn't, we create it over here. And so now what we do is we just append the category to our task.categories field. And so what this basically does is that by appending this to the task.categories field, and with this field back populates being on, what this is going to do is it's going to automatically populate this field in the category class over here. So this is basically just going to create a new category, which is what we want. So we have created a new category. We want to save this change in our database. So db.session.commit. And then we're going to return success response of our task.serialized. And so what this should do is that since we have our simple serialize in effect, if we run this, we're going to see our new category that's created, and we'll be able to see it in Postman. So let's assign a category to an ID. Let's get all tasks. Let's see. All right, so let's assign it to ID 2 and say here. Okay, so let's see what's going on. 147. Oh, this is task.category.append. Okay. Okay. So our category was now created. So now we see that our task was serialized, right? So this is our task of ID 2. We have the subtask over here, but now we have this new category over here created. So if we go to get all tasks, we see that initially there was nothing here, but now there should be something over here. So this is how kind of we can create different objects in many-to-many relationships. And so, yeah, that was it for the demo today. So to recap, we have our three models. We have our task, we have our subtask, and we have our category model over here. The task to subtask is a one-to-many relationship, and the task to category is a many-to-many relationship. And the way we implement, I guess, this many-to-many relationship is via the association table right here. We have two foreign keys that reference the ID columns of both tables. And this is how, I guess, we establish the relationship. And then for creation, when we set these fields over here, we have this back populates field, which we set to this tasks table name. And what this will basically do is that when we create a category, it will back populate to this field and also to this one over here. And so this is what allows us to create, I guess, objects in many relationships. So yeah, so that's it for today. And we can get on to the Kahoot now.